I'm presenting on behalf of Fran Marquez. I am David Daniels. Fran is my colleague at VTI, Statens väg- och transportforskningsinstitut. I am based here in Gothenburg. Fran is in Lund. Fran's project under this call is Truck to Grid, which is essentially vehicle to grid. But as we all know, vehicle to grid for grid support services has been looked at over and over and over and over and over again. The differentiator here that Fran is looking at is he's looking at a particular vehicle part of the vehicle fleet. He's looking at trucks, and specifically at medium-duty trucks in regional transport, so åkeri or regional åkeri carriers. He has a relationship. We have relationships there with several. Well, through TRB, the industry association, they can get access to the actual data on the movements of the vehicles. And so his idea, the idea here is to look at given the driving patterns of the vehicles, what is the potential then for through either smart charging, unidirectional smart charging, or bidirectional V2G in that fleet of vehicles, what's the potential for helping to balance or bring stability to the grid. And we think that that's important because unlike personal vehicles, which are dependent on consumers making choices, which is difficult to coordinate, or long-haul trucking, for which the capacity factors tend to be much higher, in regional trucks, the driving patterns are very regular. They come back to a depot every night, and so there's some regularity built into the transportation operations of those vehicles. So the question then comes up: given the regularity of the transportation operations, what potential is there for using coordinating the charging to support the energy system as well? Go to the next one. There we go. So I've already said all of this, actually. We're looking at three scenarios: uncoordinated, dumb charging, coordinated charging, smart charging, and then the bidirectional truck-to-grid charging. And we want to look at the potential under all three of those for grid support. We have another project, and this one is actually, I'm not Sarah Rönnberg either, am I? However, I am the project leader for this one for BTI. We are working with Sarah at Luleå Tekniska Universitet, although she is in Skellefteå. And we are looking on that one also at vehicle to grid, or at least the vehicle grid interactions. But here we're looking at personal vehicles. And the research question that we're looking at, this just tells who we are. So you can read this while I'm talking. The research question we're looking at is: what is the challenge, not potential in the positive sense, but the potential in the negative sense? What is there a potential for grid disruptions in the low voltage distribution networks that arise from multiple vehicles charging at the same time? So this is a very detailed power system engineering design looking at a low voltage network circuit, and then we have vehicles, personal vehicles predominantly, multiples of them charging more or less at the same time. These can create power quality issues when you have any kind of digital to analog conversion going on. If you have multiple vehicles, so if we get to a fleet which is mostly electrified in the personal fleet, then we can have multiples of the vehicles coming in. When they choose to charge, can have impacts on the power quality in the local distribution networks. We think that is an under-researched area, and before we get too far down the road of electrification, we'd like to study that and try to understand how big a problem this is and what are the mitigating actions we can take. So those are the two projects.